Now we are doing triangles with respect to the sides. When I say sides, I am talking about the length of the sticks.
Length of the side.
Sticks, sides, whatever. Now there's another concept to this. What is the concept? It is not necessary that if I say the sides of a triangle are 3 centimeters, 2 centimeters, and 1 centimeter, they need not necessarily form a triangle. We'll come to that in the second session. That's not for our first session. That's a higher level concept. We will look at the theorem and we'll also look at why that is the case. No. I've just written what Unmana is trying to tell us. She says, so that the sum of the two sides should be greater than the third side, and this should be the case in all, this should satisfy in all the three cases. That is, if I have three sides, say A, B, C, D, E, F, she's saying AB plus CD should be greater than EF, CD plus EF should be greater than AB, and AB plus EF should be greater than CD. That is what she's trying to say. Am I right, Ulmana? Now, in addition to this, there is another condition to this which says that the difference of two sides should be less than the third side. There is something more to this also. All right. So even when now, guys, we have discussed three theorems today, out of which I have given you the proof of the first one. That why the sum of interior angles should be 180 degrees. That is what you did not come across. You know, very simple proof. There's a very complicated proof also. There's a proof that takes 2 pages also. Don't worry about that. The second theorem that we discussed was the exterior angle adds up with the opposite interior angles. When I add both of them up, I get the sum of the opposite exterior angle. The proof of that I'll discuss it towards the end of the class. This is the third one. So as to why the sum of two sides should be greater than the third side, I've got certain answers from you guys. In the next session, I will compile this and give you the proofs as to why. We don't have to go into the long one-page proofs. We need to understand things logically. Remember when we were doing simple equations, how we understood the line, the graphs, why we have a graph, what are the intersection points, etc., etc. We'll do it the same way. So don't worry. All of you have given me answers that are right, but not 100% right. Maybe 98, 99%. There's some element missing, which we will clear. Don't worry about that. Now, let's come back to our topic over here, which says a triangle which has all its sides equal is an equilateral triangle. That means this is 2 centimeters, for example, this is 2 centimeters, this is 2 centimeters. The theorem obviously holds good. Sum of two sides is always greater than the third. 4 is always greater than 2. Now, who can tell me what are the angles, the three angles of an equilateral triangle? If the three sides are same, what can I tell about the angles? Go ahead.
They are acute.
Acute, okay. Are they equal? They are acute, brilliant. Are they equal?
Yes, sir.
Okay. Now, if I say that there are two sides in a triangle that are same, how many angles are also same?
2.
Beautiful. Perfect. Now, when I'm talking about an equilateral triangle, because all the three sides are same, the three angles are also same. Now, what are the three angles? If I have 180 degrees, that is forming a triangle. I divide it by 3. I am getting 60 degrees. So, A is 60, B is 60, and C is 60 degrees. Three sides are equal, three angles are also equal. This is the funda or the concept of equilateral triangle. Isosceles is a triangle in which two sides are equal.
Yes, sir. Two sides and two angles.
Yes, but which two angles are equal?
Sir, any two angles.
No, think again.
Sir, I think angles which form 90 degrees.
Priscilla, can you tell me which two angles are equal in this triangle?
Sir, in this triangle, A angle,
Okay.
A and angle B.
Beautiful. Angle A and angle B. Now, AB is the unequal side. AC is equal to BC, which is not equal to AB. This unequal side is nothing else but a base. As simple as that. Now, because we have two equal sides, that is AC and BC, angle A and angle B are the same. Are we through? This is the concept of isosceles. Now, the last triangle that we have is simple. Scaling. No three sides are equal. It becomes a scaling triangle. AB is not equal to BC, which is not equal to CA.